This guy is named Ernest Rutherford, and he was a physicist in the late 1800s, early 1900s. And he did a really, really amazing experiment in which he discovered the nucleus of an atom. Before Ernest Rutherford, we didn't know that the atom had a really thick center called the nucleus. So here's how he did it. He used this experiment called the gold foil experiment. And what he did was he took a laser beam that sent these particles that are called alpha particles really rapidly at this piece of gold foil here. And what he expected was to see that the particles would pretty much just go through the foil. But the amazing thing that happened was that some of the particles bounced back. Now, this might seem pretty unremarkable to you because looking at this piece of gold foil, well, it's a solid, and if you send something at a solid, it's probably going to bounce off. But the way that he describes it, the reason that he says this is so amazing is he says, imagine throwing, a piece of lead or something at a piece of tissue paper, and it bounces back off of the tissue paper. So what he's trying to explain is that these little alpha particles, they're really, really dense, and they should be able to just go straight through the foil, maybe ricochet off a little bit, but pretty much just go straight through. But he was seeing particles that were going off at 90 degrees and even more, coming back at them the way that they came. So this was really amazing. And at this point, when he did this experiment, scientists thought that the atom was pretty much mostly made up of empty space. But this was evidence that it's not made of empty space. So before Rutherford, this was the model that everybody was using, and this was J.J. Thomson's model. This is the plum pudding model. The idea was that you've got this kind of mass, this shapeless mass that has a bunch of electrons stuck in it. And so these particles, these alpha particles that are positively charged, they have protons in them, they just go straight through and they don't have any problem. But since that wasn't what Rutherford observed, he came up with a new model of the atom. So the idea here was that the atom is actually made up of a really, really thick nucleus in the center, made up of protons, which are the red dots, and neutrons, which are the gray dots. And so when he would send these alpha particles, which are made up of protons and neutrons, very, very teeny tiny itty bitty little ones, they're actually like they're hydrogen nuclei. The nucleus of a hydrogen atom is one alpha particle. So they're also positively charged. And what we know about things that have the same charge, kind of like a North Pole magnet and a North Pole magnet, the same magnets will repel each other. Opposites attract, and like things repel each other. That's exactly what's happening here. So we're using our little gun to fire all of these different little atoms. These, not atoms, but these alpha particles. So we can do a few things here to try to change what's going on. We can give the alpha particles some more energy, and you can see that they're getting closer to that nucleus. And you can see that there's some that are just going straight past because they're not close enough to the nucleus to be deflected. If I decrease that energy down, and they're going a lot more slowly, you can see that they can't get as close because they don't have as much momentum. So I can do that. I can also show their paths so that you can really see the path that they're following. And I can also change the property of this atom. I can decrease the number of protons that it has. And when I do that, you can see that it doesn't have as much repulsion against these alpha particles because its overall positive charge is less. If I have more protons in there, then it's more effective. So here's a little less effective, and even less effective. Really. Ooh, it's getting super close when you do that. All the way down to this. Now they're really getting close. So the fewer protons we have, the closer they can get because there's going to be less repulsion between the protons in this nucleus and the protons in these alpha particles. If I change the number of neutrons, that has a little bit of an effect. You can see that some of those particles actually touched there. Fewer neutrons, and they're still not getting as close. Here you go. And that is Ernest Rutherford's gold foil experiment and how he discovered that there is a nucleus at the center of all atoms.